I'm here with David Wilson of Wilson Audio. Thank you very much, David, for the interview.
My pleasure.
Okay, now I should start, I suppose, by saying or wishing you congratulations on the Sasha winning so many awards worldwide. Now, in discussing the changes between the already outstanding What Puppy 8 and the new Sasha, could you expand on what led to the technological developments firstly, and secondly, could you discuss the sonic attributes that you were looking to build upon from its predecessor?
Mm-hmm. Yeah, the mid-range driver is a key element to the improvement in the Sasha, and we had, by the time development work on the Sasha came along, we had accumulated quite a bit of experience with that driver. And we knew the things that it does, frankly, I think uniquely well. Its ability to resolve detail in the mid-range without being analytical or anything. Its wide dynamic contrast. It has a low noise floor, so it resolves low-level details. So the Sasha architecture, well, the What Puppy architecture is good for exploiting those qualities. You have a small front baffle for minimum diffraction, and a very rigid non-resonant enclosure, and a hard non-resonant baffle material for the driver to work against. We wanted to retain the qualities in the mid-range that we knew that that driver could provide, and we also wanted it to be even more linear in the mid-range than the What Puppy 8. The What Puppy 8 at times could be a little bit forward in parts of the mid-range. And so that region was able to be linearized with the Sasha, with no loss of resolution or anything like that. The tweeter received an improved rear wave absorption mechanism, which reduced its noise floor, so that it provided a good match with the mid-range driver. The crossover topology is similar to the What Puppy 8, but the crossover that normally would fit inside the upper section is now out of that section, giving more air volume and less reflected energy within the small upper enclosure. And the crossover is now mounted down in the woofer compartment. It's further away from the magnets. And so it's freer. It's a cleaner sounding crossover. And then the enclosure volume in the woofer section is larger, and the motor structure is more powerful in the woofers in the Sasha Puppy section. Sure. So the dynamic range of the system has been extended. The linearity is improved. The settling is faster. It's a very musical speaker from the standpoint that it tends to get more out of the way and have less of an intrinsic sound itself.
Sure.
The What Puppy 8 was a result of many, many years of evolving technology.
Yes.
So it was a very refined product. But I felt that it was necessary to make a fundamental change in the architecture of the system by removing the crossover from that upper section and by reducing the cabinet signature in the upper section. Sure. And so the shape of that, which appears to just be an ornamentation, is also functional.
As you were referring to the flare at the bottom of the...
Yes.
Yes, right. Mm-hmm. Okay. Yeah. Mm-hmm. Okay, just going back to the crossover which you mentioned, another topology has always been a bit of a trade secret for Wilson as far as the crossover. However, you talk about implementing jitter reduction technology in the current series of crossovers. Just wondering if you can expand on that a little bit.
Yeah, I can't go into a lot of detail, but jitter is usually associated with instability of speed in digital data transfer, and it's a timing error. In a way, the jitter that we're referring to in the crossover network is also a timing error in terms of mutual, induction of signal from one element into another, and so reducing that so that you don't have, let's say, information from the low frequency section of the crossover in any way electromagnetically bleeding over into the tweeter section. So that's part of it, and there's some obvious ways of doing that, and then there are some ways that are less obvious that we've discovered over the years. And so there probably is a better descriptor than jitter reduction for this, and yet it's so similar to the jitter phenomenon that we've seen when we've measured cables during their break-in period. There was one brand of cables that was remarkable in the difference of its sound between when it was freshly taken from its package and then the sound 2 days later. And so Vern Curdell worked on a way of trying to measure that, and he succeeded. And he refers to it as a jitter phenomenon. And to a certain extent, it's related with what we're talking about here. It's very real when people say, well, you need to let the cables calm down. They vary. Different brands of cables vary based on the physical properties of the insulating material and the geometry of the conductor twisting and the way the conductors are assembled. Sure.
It's interesting you mentioned break-in because in the last two generations of Wilson, Watt Puppy and the Sasha, I found that, and some colleagues of mine found the same thing, that the speaker sounds tremendous straight out of the box. But over the next few days or so, the sound just deteriorates a little bit and becomes a tad lifeless and almost brash, and then it progressively, over maybe a period of 200 hours, gets better and better until at roughly the 200-hour mark it turns into a superb sound. So I'm just wondering what your thoughts were on that sort of, and whether you've conducted any studies to examine that phenomenon.
We have, but not with as much in depth as it probably deserves. We do, as you may have seen in our QA lab, we do break in all the woofers and mid-range drivers. We've also recently developed a protocol for breaking in the tweeters. But a couple of things that we know happen. One is we know that the crossover components will generate a charge when they're being manufactured, and if you, when you're setting up the speaker, walking around on a carpet, you can build up a static electricity charge yourself, and if you touch the frame of the driver, it can induce a current into the crossover network and cause some charging. It might be useful for us to ship the speakers with a shorting plug or cable across the terminals to drain that down. That's something that we might experiment with. Another thing that is that a lot of our speakers are shipped by air, And the cargo compartments, they go through quite a wide temperature range sometimes. And I think it affects the elastomeric suspension on the tweeter, and it may introduce some stress to that takes a while to work out.